So in this lesson, we'll be further building our knowledge in algebra. We'll be covering exponential equations and inequalities, how to draw number lines, and how to represent our solutions, really. So how I've structured this lesson is that I've taken three common patterns in exponential equations, and namely, let's label these number one. The first one is the basic type, and the second one is a trinomial type. And the third one, it's where it's a bit advanced, where it needs to factorize. So really, examiners follow pretty much this trajectory when they set these questions. So also, the exam is not only limited to these questions, but more or less it covers the scope of work. So in the first one, we're given that 3x plus 1 minus 3x minus 1 minus 24 is equal to 0. So since this is the basic type, and how to spot that is that really you'll be able to see that there's 3x and 3x. Automatically you must think that you might be taking out a common factor. But first things first, you're supposed to take this number to the right hand side of the equation so as to isolate it. Then it will be positive 24. Then we split really this expression from x to the power of x plus 1 to x times 3 to the power of 1, because you know those are exponents, same basis, you add exponents, but now we're performing it in reverse. And here we do the same thing, 3 to the power of x times 3 to the power of negative 1 is equal to 24. And then we take out the common factor, which is 3 to the power of x, meaning that we write 3 to the power of x, open the bracket, we have 3 to the power of 1 inside the bracket minus 3 to the power of negative 1, or equals to 24. So if you wish, we can just really simply punch everything here into the calculator and see what you get. It will be 3 to the power of negative 1, and you will see that you'll get 3 to the x, in brackets you have 8 divided by 3 is equals to 24. And because we really want to isolate anything that has x, we're going to divide both sides by 8 over 3. And if we divide both sides by 8 over 3, on the left hand side we have 3 to the power of x, and on the right hand side we have 24 divided by 8 over 3. And you should write down the solution. You can really punch this into the calculator, and you see that you will get 9. And 9 can be written in terms of 3 by saying 3 to the power of 2. 3 to the power of 2 gives us 9. So therefore, laws of exponents, when two exponents of the same base are equated, you drop the bases and you keep the exponents. So therefore, x is equals to 2 will be our solution to the question that has been given. So that's really what I refer to as the basic type, or where you have to really take out the common factor in most cases. So let's move into the next type of question, where really we're given that 3 to the power of 2x plus 2 times 3 to the power of x is equal to 3. So with this type, I refer to this as the trinomial type. So let's just quickly relabel these. I refer to this as the basic type, where you have to take out the common factor. And thus I refer to this as the trinomial or quadratic type. And why do I say this is the quadratic type? Because automatically I can see that I have 2x and I have x, and they're both having the same base. So automatically I have something of a quadratic fashion. And how do we really peel that out to reveal that? We can write this as 3 to the power of x, and we say squared, because this is the same as 3 to the power of 2x, because x times 2 is 2x, plus 2 3 to the power of x. You can bring the 3 to the party, it'll be negative 3, and we can see that 3 to the power of x really is a common theme, but it's not a common factor. But really, there's a trick that I'd like to share with you that's really helpful in such a situation, so that you can really see it clearly. We can say we can let 3 to the power of x be equals to k, meaning that where there's 3 to the power of x, we substitute in k, meaning that it will be k squared plus 2k minus 3 equals to 0. Now you see that we have quadratic factors of 3, 1 and 3. How can we write the signs of 1 and 3 to give us positive 2? You can say positive 3 minus 1, 3 minus 1 will give us positive 2. Minus 1 times 3 will give us negative 3. So these are our factors where we open two brackets, equal to 0. We have k, and we have k, negative 1 and positive 3. So we can see that k is equals to 1, or k is equals to negative 3. But remember, k is equals to what? We said k is equals to 3 to the power of x, meaning that we substitute back 3 to the power of x equals to 1. Remember, 1 is nothing more than really any number to the power of 0, meaning that since we have a base of 3 here, we can say 3 to the power of 0 is the same as 1. Therefore, one of our solutions will be x is equals to 0, because when two exponents are greater than the bases are the same, we drop the base and keep the exponent. And the other solution is it's 3 to the power of x is equals to negative 3, and we know that here there won't be any solution, because an exponent equated to a negative, really we can't really get a solution, or it's non-existent. So our only solution here is x is equals to 0. So take note of the two types, and really we'll move on to the next type now. So the next type is the one where we're given really a random equation and it looks a bit intimidating. So what I'll do is I'll erase all our workings here, and I'll try and move all this works so it's visibly clear. So we'll label this number 3. So I like to refer to these as really the advanced questions, because really there's no one way of answering these questions or memorizing them. It just depends on what the examiner brings, and really most of the time it includes factorization. So what we have here, we have 5 to the power of x minus 1. At the bottom we have 5 to the power of x plus 1. So if you look closely, we have 2x at the top. So let's just rewrite this so that it looks a bit differently. You can say 5 to the power of x squared minus 1, 5 to the power of x plus 1 is equals to 4. So let's just move our workings so able to visually see what we're doing. So we can see that at the top we have something that looks like a difference of 2 squares, and it will make sense because if we apply difference of 2 squares on the numerators, we can see that we can match the denominator and this variables can cancel. And if we apply difference of 2 squares on our numerator, we'll have 5 to the x minus 1 and 5 to the x plus 1. At the denominator we have 5 to the x plus 1, and all of this is equals to 4. And remember, if we have two identical variables at the top and they're multiplying at the top, they can cancel, meaning that we have 5 to the x minus 1 equals to 4. Isolate 5 to the x, we have 4 plus 1, and we'll have 5 to the x is equals to 5. And you know that any number with no exponent has actually a number 1. We drop the bases and we keep the exponents, therefore x will be equals to 1 will be our solution for this problem.